Hello, everyone. So I know we have mentioned like the session is under NDA, but unless you see under NDA or confidential on a slide, which I believe you will never see, because pretty much everything that we're going to go through is publicly available information on this session. So feel free to share whatever you want during my presentation here, at least as long as you don't see under NDA on your screen, on my screen. I will let you know. The one thing that I might ask for you not to share is the moment I share my Azure portal, if you see any keys, any secrets, keep that as a secret. I will try to regen those after the session, but let's keep it between us. So, okay, cool. So let's start. Okay, what is the topic, right? I mean, living on an end-to-end serverless architecture on Azure. So the goal for this session is to give you the full picture in terms of, hey, if I wanted to live a serverless world, whatever that means, we're going to go through that the default definition as well, at least my definition and my understanding of it. So if we wanted to go that, that direction, what does Azure has to offer? Right. Let's go. So obviously the first thing to do was to kind of define what serverless is, and I will bring my own description of the serverless, which is gonna be the whole, overarching definition for the rest of the session as well. And you might find it a little bit interesting that, first off, there are burning servers. Now that we can generate images the way we want, I kind of put images everywhere on this slide deck. Anyways, so it is. What is that thing? GB per second. Okay, so that's a unit. That's a unit. What is it? It's gigabyte per second. What type of a unit that can be? And to me, that's the definition of serverless. And let me explain. So when this whole cloud thing came in, right? When was that? Pretty much 10 or maybe 15 years ago. The idea was that, hey, you come in, you use as much as you want from these resources. Your application will be able to scale literally indefinitely, let's say, right? You're not going to need to worry about it. And you will only pay for what you use. So that was a dream this whole thing started from. Obviously, where we're at today, if you look at a lot of the services, what you're going to see is that the service asks you what you are going to provision. And if I will be provisioning something, that doesn't sound like it's serverless. So the whole concept of serverless is, I shouldn't care about the service. Again, I'm not going to say that today where we're at with serverless is definitely, it's disconnecting us from the reality that there are servers out there. It's not, but at least that's the furthest we could come so far, right? That's the most ideal that we were able to come so far. Okay, so what it is, pay for what you use, not for what you provision. Again, this is my definition of serverless. Okay, I'm taking full responsibility on this, but this is not necessarily Microsoft's definition of serverless. Let me put it that way, right? I'm not sure. I didn't double check, but this is my understanding of serverless. So I'm not going to provision anything. And again, if you go out there and look, there's a serverless wash going on. Everything is called serverless. So yeah, my definition. You don't provision anything. You only pay for what you use. You shouldn't come in and, I shouldn't ask you like, hey, what might you be using? Do you have an estimation about the load that your application would have so that we can provision some stuff? No, that's not serverless to me. It has to have transparent auto scale. At least it should have that. What does that mean? I don't know how much load my application will have right now, a second later, or tomorrow. And the platform should be able to take care of bringing enough infrastructure resources or whatever I need based on the load that comes in transparently to me. By transparency, I don't mean I'm going to see the result in my end of month invoice for sure from the service provider, but at least I shouldn't be woken up in the middle of the night or be, send some alerts or whatever. I shouldn't configure anything. It should just auto scale, make sure that my application is available and is able to serve my customers. So that's what I mean with transparent auto scaling. The other thing is ability to scale to zero. Okay, that's an interesting one. And, there might be discussions around, hey, this is a .NET app. We want to keep it warm. There are workarounds for that for sure. And it's not just .NET, it depends too, again, the language and the framework that you're using, obviously. But ability to scale to zero in this case means to be able to scale to zero in terms of consumption. So if my application is not being used, I don't want to pay anything. That's what I mean. I mean, you might be keeping something warm and hot, or, you might keep some, provisioned resources for me. I don't care. As a service provider, if you do that, that's your decision. I shouldn't be paying for it because I'm not using it. I want to pay exactly for what I consume or what I use without provisioning anything or provisioning resources. Provisioning something that I pay for. That's my point. Okay. So then there are two large, elephant in the room type of situation that we have to cover, which is the confusion around, hey, we're talking about serverless. Are we talking about, containers? Not necessarily. No. I mean, a serverless platform can use containers as a, packaging, deliverable, whatever, method. Containers could be used that way or might not be. We could be using something else. So the sandbox could be, related to something else as well. So not necessarily. It doesn't, doing serverless doesn't mean that we have to containerize our application. That's a totally separate discussion. So you might see, not necessarily in Azure, it depends on the service that you are using. So again, some services, they have that decision, they have that opinion that, hey, we're going to do serverless through using containers. Some other services might be like, oh, no, I'm going to use something else. I'm going to simply use zip files, whatever, right? So we will see some examples of it from Azure as well. I mean, next slide should have some of those. So the other thing that we need to cover is serverless and microservices. Oh, man. And maybe I should have put here serverless and function as a service and microservices. Anyways, so no, they don't have to go together. They might go. So you might say like, oh, yeah, I'm going to do microservices. I'm going to, vertically separate my app, on all the layers and have, separation. You might want to do that, or you might not. So you can have a fully monolith application as a serverless app. That's totally up to you, but you can do it. So then what is this serverless thing that we're talking about? Obviously, function as a service is a little bit different, right? Maybe. So it kind of focuses more on the event-driven development. But when it comes to serverless, again, transparent auto scale, ability to scale to zero, and you don't really care about how I architect my app, right? Microservices or not, containers or not, whatever. It can be even a monolith. So what is this thing that we call serverless if it is not related to it doesn't have to be related to the architecture of the application? Let's go to bullet item 1 in our list. Gigabyte per second, what that is. That's a billing unit. Okay? The amount of memory you use per second. And that's how I bill you. At least that's the best that we have today. Actually, we do it, if you go with Azure Functions, we do it on a millisecond level. Maybe in the future, we're going to come up with something more granular. But it's all about the granularity of this platform in terms of, again, remember, I'm going to pay for what I use. Granularity is critical so that I really pay for what I use. If I've used 500 milliseconds or 2 seconds of that processor, I just want to pay for that 2 seconds. And obviously, when I'm using the processor, I'm using some memory as well. So I should pay for the amount of time I have used that processor plus the amount of memory I allocated. And that's where gigabyte per second comes in. And I wanted to put this on top of my list because today, it is my requirement, like having a highly granular unit of consumption so that my pay-per-use graph, if there's such a graph, gets really closer to what I really use in terms of the infrastructure resources. So that's why I put that item on top of my list. Okay, so with that done, taken care of, let's jump into level by level everything that we need building applications. Always the first thing that we need is compute. When we are building an application, putting it somewhere, again, when we're talking about serverless, it can be a full-blown serverless app. It can be something small, right? When we start talking about function as a service, maybe it's just a little function. You can think of it like, maybe like the store procedure on a SQL server, right? That's a little thing that you put in, maybe create some kind of triggers and stuff. So maybe that's what you need between you have multiple applications and you're going to glue them together with a little function. That's where function as a service might come in. That concept might be more helpful in terms of understanding what's going on. But let's look at the entire compute platform. So we got three big pillars, right? The first one is functions, Azure Functions. That's the one that brings in gigabyte per second granular billing plus execution count, the number of times you have executed. Okay, I'm not talking about the inbound bandwidth, outbound bandwidth. Obviously, those are going to have whatever you use. If there's something being inbound and outbound, whatever, you will be paying for that for sure. That's outside the scope of this slide. So millisecond level billing. Right, the billing is on the second level, but the calculations are being done on the millisecond. And at the end of the month, you're going to see, on the bill, you're going to see per second billing. But during the execution, if you take a look at the logs and how it's being calculated, the aggregated result will be on seconds. But the logs you're going to see, it's going to be on the millisecond level. And built-in auto scaling and auto provisioning. I have a very nice demo. Stay tuned. So built-in auto-scaling, auto-provisioning. Whatever load comes in, I'm going to scale it for you. You don't have to do anything. I'm going to take care of that for you. I'm going to auto-provision additional resources whenever your app needs. I will pretty much do event-driven scaling in here. So, and these features are available on something we call consumption tier. So there are different pricing and provisioning models for all of the services that you see on your screen right now. The one that I am focusing is the one that is closer to being serverless. Okay. So, and with that, think about it. The way I am using serverless, it looks like throughout this whole, spiel is, doesn't that sound like is it like a licensing model? Is it a billing model? Is it licensing model? It doesn't have anything to do with the architecture. It doesn't have anything to do with how I built the app. It can be a monolith. And now you're all talking about, how I'm being billed and, measured my consumption and so on and so forth. So it doesn't look like it looks like this is a licensing model. And I'm going to put that question out there and open. Okay. Food for thought. Okay. The second item we have on screen is container apps. So in this case, the units you might have noticed is a little bit different. We got virtual CPU per second. Okay, so we got a full CPU per second. The other one wasn't necessarily a full CPU dedicated for me. So virtual CPU per second, I'm dedicating a virtual CPU. I'm still paying for the memory, and then I have a request count. But what's different in this case is that I'm deploying containers. And this whole platform is running on AKS. Okay, so whatever I do is pretty much compatible with the whole Kubernetes, infrastructure. So second level billing with consumption tier. So that's important. And by that I mean, by the way, when I read it right now, it sounded weird, but what I mean is per second billing, right? Per second charge. It comes with the consumption tier that I mentioned previously. So there is a configurable auto scaling and auto provisioning. So it's configurable. It's still native to the service, but you have to configure that. So when it comes to Azure Functions, you can obviously still configure it, but by default, when you go into Azure Functions consumption tier, the last time I checked, if I'm not mistaken, it was up to 100 servers by default. It will scale up to 100 servers by default without asking any questions. So you only worry for the execution time and the memory that you use. That's it. It's not going to be the case by default with container apps. So you have to go and configure. So you have to be more intentional in this case. And that's perfectly fine. That's not a huge deal. You're still paying per second per processor and the memory and the request count. So these two are pretty much similar. So then we have... So to be honest, the product page says AKS serverless. I didn't find it very clear. So I've used the AKS logo with virtual nodes because it's what's happening. So you're having virtual nodes supported or powered by Azure Container Instances. So what is Azure Container Instances? You give a container, it runs on a VM. That's it. You don't manage the VM, but it runs on a VM. So, and in this case, you still pay, you decide what configuration that particular VM will have. So let's assume we're going with a one processor, one virtual CPU. I'm still paying per second. I'm still paying for the memory. Plus, most probably I will be attaching this ACI with virtual nodes into a current AKS cluster or something. So there might be additional costs of having that AKS cluster up and running. So that's why I wanted to put plus AKS cost. So there's still per second level billing through ACI this time. Thanks to the container instances, I'm still enjoying per second billing. So when it comes to auto scaling and auto provisioning, obviously that all needs to be configured as part of your AKS configuration in this case. Okay, cool. So these are the high level options that we have when it comes to serverless. And with that, it's time for a demo. Okay, so let me do this. I'm going to bring some stuff, but first, give me a second so that I bring the right stuff to my screen. Just a couple of seconds. Okay, let me bring this in. Here's what we're going to go. Let's go to the resource group and let's go here. So here I have a function app that is already deployed. So let's look into the functions that we have in there. Where are you? Okay, there we go. So I have a function named say hello. Okay, this is a dummy function, by the way. What this function does is it simply waits for a random amount of time before responding. So this is simulating a blocking API. Think about an API that takes 5 to 6 seconds to respond. So I'm going to get the URL and I will try to run that. Let's see what happens. That is interesting. I'm having this problem a couple of times today, but let me go this route. I don't know why. There must be something weird with my browser. But I know this is working because I've tested it like 30 minutes ago. Give me a second. This will work. Okay. Come on. Okay. So I got an HTTP 200. And it says slept for 7 seconds, 7,000 milliseconds. So I will give another try to the URL. I can actually pass the old one. That is weird. Let me get this one. Okay, great. It's gonna work. I feel it because it's making wait, which is what it is supposed to do. Okay, this time 6.9 seconds. So this is an API that no one wants to have. Obviously, an API that takes 7 seconds to respond. We don't like it. So here's what I'm going to do. I have this API. For some reason, it's doing some stuff for 7 seconds. Now, let's go take a look into, I'm going to open another portal. And I will go and open up the application insights attached to this function app so that we can see how the underlying infrastructure is behaving. So let's go there. Go there, go there, go there. Here's application insights. And we will go to, where are you? Where are you? This one? Okay. So here I can see the live metrics. This is real time. When I scroll down, you're going to see that I have 2 servers. This application insights is connected to 2 different services. So that's why we are seeing this one. Actually, this is this random guide that we see. This is the one that comes from the function app. Okay. So because this application insights is ingesting multiple, incoming logs from multiple services, we do see another server as well, which has nothing to do with the function app. So I have a single server right now provisioned for me. My application is deployed, ready to respond. I'm not paying for this. I'm not paying unless there's an API call coming in. Isn't that beautiful? It's hot, waiting for incoming requests, deployed. It actually has memory footprint. I'm not paying for it right now unless it's being used. Okay, let's do this. I'm going to bring this one here, which I like. This is an Azure load testing service. Okay, so I'm going to paste my link. I'm going to do some load testing. I will put 50 virtual users. Doing 200. You know what? Let's make it 100 virtual users. I will give no ramp up time, and I will run the test. So I will start hitting load testing my function app. So at this point, this is going to take a while. The reason is right now Azure load test will go and provision a cluster for me so that it can start sending requests to my function app. While it happens, I will go back to my slide deck and we will continue with the topic, but then we will be back. So let me move this outside my screen so that I can still monitor that, because we will need to come back to that when it's ready. Meanwhile, keep in mind, I mean, the telemetry is still live. I'm still listening for the telemetry, and we will see some stuff in here. You will see right now it says how many? 2 servers online. Again, one of the servers are for something else. 1 server -1 all the time. And the testing is in the provisioning state. Cool. So what else do we have? Yeah, we will do that demo. The next section is data. I have apps. Okay, I've managed to get it totally serverless, scale to 0. Don't pay for it if it's not used. Beautiful, but an app is not just compute. So what can we do with data that might be serverless? Or in my case, you know, my definition of serverless, which is pay for what you use and auto scale and all that. Did you guess this? Were you able to foresee this? Okay. Cosmos DB. I'm gonna bring in the big guy. So obviously Cosmos DB has, you know, it's an amazing product. Oh, by the way, okay, executing. It says executing. Let's go back. Okay, let's wait. Okay, it looks like we got a couple of requests coming in. Oh, server number 5. Look at that. I got 4 servers. My function app has scaled to 4 servers. Obviously, the number of requests they're able to serve is very limited right now because I'm blocking the servers. So yeah, so that's not a good thing to do. But you can see, you know, I'm up to 7 servers, or 6 -1 all the time because of this other thing that is out there. But I got up to 6 servers right now. I didn't do anything, by the way, right? Just load incoming load to my HTTP endpoint. You see the latency did spike for a moment, but then I got a pretty stable latency. If I go and take a look at my load test, it looks like we are sending around 15-20 requests a second, which isn't, again, a lot. But again, keep in mind that those are 7-second runtime, you know, requests. Okay. So let's look at it. 10 servers. I mean, to be honest, we can go up to 100 servers or even more if we wanted to. But this is all. And by the way, right now, what I am paying for is the amount of execution time that I have, right? The moment this task stops, and it's going to, I guess we set it up to 2 minutes. So maybe I can stop it manually because we have seen what we wanted to see. So let's stop it. You're going to see that all of these, you know, second request counters will go to 0, obviously. Give it a little bit of a time. It's eating up from the queue, probably. We're done. Okay. So we still have 11 servers where our application is deployed, and those servers are provisioned for us. They're not working because there's no incoming request. And I'm not paying for any of these servers right now. I got 11 servers hot to go. The timeout probably is, if I'm not mistaken, it was 5 minutes before deprovisioning happens. But the point is, I got 11 servers provisioned for me. My application is deployed, but because no one is using my app, I'm not paying for it. So if I get another spike right now, I have already 11 servers ready to go. There isn't even, but you have seen the provisioning speed, right? It was, yeah, it's crazy. Okay. Let's go back to our Cosmos DB. Demo successful. Cool. So when we go into Cosmos DB, there's this concept called request unit. A request unit itself, it encompasses everything. What does that mean? The complexity of the query in terms of, the processor the query used, the memory the query used, the I/O, the disk I/O the query used. What else? Oh, yeah. I'm not going to go into, this is going to be a full Cosmos DB presentation, obviously, but you can select the consistency levels and all that. So based on the consistency level, obviously you're going to be using less or more processor power, or indexes related to that. All of that is bundled into a single request unit, which is the cost of a query, which means obviously I'm going to be paying for the storage of the data as that's a separate thing. But again, if you look at the storage, you're paying for what you store. So it's, by this definition, it's serverless. And actually, I don't have it in my slides, but data lake based on Azure storage is called serverless data lake nowadays. So anyways, so here I'm sending a query and I'm paying only for that. And that's it. I'm paying for the amount of data that I store. I'm paying per query. There are different, billing plans, by the way, if you want to, but I'm talking about the consumption plan. The point was, if I don't send any query, I don't want to pay for it. And that is available. Only data storage. Obviously, I will be paying for that. So I don't have to plan for anything. If there's a lot of load coming in, there's a performance SLA already out there. So it will scale. It will make sure there is power enough, because for every query I will be paying. Okay, so let me see if I missed anything from my slide. Handle traffic bursts, yes. No resource planning, yes. Bills only for resources used, yes. So what can you do with this service? You can store documents. It's a NoSQL service. So it has APIs for MongoDB, Gremlin, table storage, if you're interested in that, Cassandra APIs, 5 different consistent levels, and there's SLA on 4 axes: availability SLA, throughput SLA, consistency SLA based on the level that you have chosen, and there's latency SLA. So all of these SLAs will be covered in an environment which is going to auto scale based on the query load that comes in. Isn't that beautiful? And on top of that, if you want it, so obviously you can have turnkey global replication as well, which is a feature of the product. Okay, so I want to show you something. This isn't going to be a very sexy demo, but still, I just want to show you something. Okay, let me see. Where is that? I have too many tabs. Not this one. Too many tabs. Or maybe not enough tabs. Okay, let's go. Let's close this one up. And I will go here and pick my Cosmos DB. So there's only one thing that I'm going to show you. So let's go into Data Explorer. I have a collection in the database here with some, fake data. Anyway, sample data, not necessarily fake. And let's go into there. Okay, so here, not necessarily a new item, so let me go. Give me a second. I will manage. Okay. New SQL query. I know I said this is a NoSQL database. You can write SQL, T-SQL queries against it. Okay, select star from C. This might be hard to see, but okay, there we go. Select star from C, and I will execute this query. So I'm simply selecting everything from this collection. It's a relatively long collection. But what I want to show you is this part that says query stats. When I go in there, you see the thing called request charge. So for every query, I'm not only getting back the data, I'm getting back how much it did cost for me. For every query, you get that data back. So imagine the level of optimization you can do. Because right now, optimization means this is one-to-one reflected to my end of month bill. And if I send only one query, this is what I'm going to pay for. And that's it. one interesting thing I want to show you is, let's look at the data. Okay, SQ. Let's put a, first off, keep in mind that this query, select start from C, that cost us 8.3 RUs. So let's do this. I'm going to put a var close and say c.sq equals this little guy. So what do you think is going to happen? Do you think this query is going to cost more or less? Isn't that interesting? So 8.3, when I simply did a select star, potentially it's not a very complicated query, right? In terms of, there's no scans or anything, pretty much. Okay, let's run this query and see what happens. Oops. Oh, yeah, sure. There we go. This is more friendly. Okay, so I got obviously one object back, and let's get the query stats. 2.8. Oh, even though this query is a little bit more complex, the amount of data that I'm pulling out of the index is much smaller. So it looks like, in terms of Cosmos DB, a select star is, maybe this isn't news for some of you, but this might be interesting to think about. Those different queries that we write, and you can get this feedback real time back, right? And this is a serverless way to implement, this is one option when it comes to data. Again, we want to have an app that auto scales, right? Auto provisions based on the load and can scale down to 0. In this case, maybe the only argument might be, hey, I will still pay for the data that is stored out there, but come on, that's pretty much obvious. Okay, perfect. So let's move this away. Got that. So the second option, SQL Database Serverless. Okay, let me tell you this. There's a reason I've ordered this list and started from Cosmos DB, and now I'm talking about SQL Database Serverless, because we will slowly get a little bit away from that ideal serverless world, but still it's a step. So here what's happening is we are paying for compute used per second, but we have some limitations, right? If you look at this graph beautifully explains that. We have a minimum vCore that we always provision. Again, this isn't lovely. This isn't the ideal serverless world that I want it to be, but it's a step forward. And then I have a max vCore. Again, you might argue that, hey, this goes against your indefinite auto scaling, auto provisioning. Yeah. But then here's the huge benefit, right? First off, between the min core and the max core, if you look at it, my consumption, which is the orange graph, equals to the build virtual cores. So as long as I'm between the min core and the max core, I am only paying for what I use. As long as I'm between these two lines, I am fully serverless. So that's nice in terms of the granularity of the billing, right? So that's a good one. And then if you look at here, there's this option to scale to 0, not always, but if you got an idle period, which can be configured. So if your database has been idle for a while, then it goes to 0 and you don't pay for anything. And I know some of you would say, hey, what about cold start? You're in the cloud. If you're developing cloud stuff, distributed applications, I'm sure you have retry logic everywhere. So as long as you have those retry logics, you are safe. You wouldn't trust on that TCP connection to the SQL server. You shouldn't trust it anyways, to be honest. And this is right now pretty much built into a lot of at least it's built into framework and stuff. So yeah, I remember the first days, not necessarily the first, but the beginning of the cloud journey when Inti Framework didn't understood anything about SQL Azure. Anyways, I'm showing off my age. So this is another option. This is not as ideal as Cosmos DB maybe, but this is the SQL that we know, and we can scale down to 0, right? And we do have a pretty nice pay-per-use story between our min core and max core. What else do we have? Option 3. Now, this is an underrated service. Really. Azure Table Storage, a very underrated service. I do understand that it's not highly scalable. You have to squeeze yourself into its feature set, which did expand, by the way. If you didn't look into table services for a couple of years, I strongly suggest to taking a look at it, because if your requirements match, Azure Table Services, by the way, is a NoSQL database, not document-based. I'm not sure what to call it, to be honest, not necessarily a key value as well. But it's a NoSQL service. And if your requirements fit into the functionality that you can have from table service, you pretty much found the cheapest database ever. Okay. So storage is on, obviously you pay for what you store, then you pay per the number of transactions you do. And that's it. The number of transactions. I'm kind of taking a look at my, obviously there are upper limits, right, in terms of how much it can scale. Okay. But it's a service that I pay for what I use and works pretty nicely. It's flat non-relational data storage. I'm kind of reading my slides right now. No secondary indexes, kind of the limitations. Again, it's a very limited product. By the way, there is a table API under Cosmos DB. This is not that. This is the classic Azure Table Storage that comes with every Azure Storage account, unless you specifically selected a blob, only blob-based Azure Storage account. Okay. Crazy low cost. This is another one that I want to talk about. So, okay, we did kind of cover the data scenario. We did kind of cover the compute scenario as well. So, what about integrations? So, applications do not live alone. They communicate with other apps, external, internal, or sometimes we might have an application that has multiple pieces, such as maybe microservices or multiple function apps and so on and so forth. So they're going to talk to each other. Is there a serverless thing that I can use when it comes to integrations? And yes, there is. And that's Event Grid with a beautiful image generated with AI. Okay, per event billing. That's it. As simple as that. You go get yourself an Event Grid. It's a beautiful service, by the way, because it's one of the very unique services that can deliver events outbound without doing any polling or anything like that. So you can do events between Azure services. Event Grid, by the way, is natively implemented into Azure as well. So you might see, like, if you go into the Azure storage and you want to be notified when a blob has been uploaded, you don't have to do a polling anymore, which was the only thing you could do maybe 5 years ago. But right now you can simply subscribe to the Event Grid topics of Azure Blob Storage, and you will be notified, right? So Azure in itself has all of those Event Grid stuff implemented, and you can be a publisher yourself as well. So your app can be a publisher. So you can use Event Grid to have, eventing communication, not messaging. Okay. Unfortunately, we don't have, I don't want to position Azure Q as a messaging infrastructure. But, this is an Event Grid, eventing infrastructure, not a messaging. But you can work on that if you really want to stick with the serverless approach, right? The point is you don't pay anything if there are no events at all, and you pay per event, and that's beautiful. And you can implement with external services, internal services between your apps. So that's one option. And then I'm going to bring something interesting that I believe you're not going to expect me to bring in. Logic apps. Okay, Logic apps. So Logic apps is this interesting thing, because when it comes to, hey, we're developing an app, I don't think anyone thinks of Logic apps pretty much. because it's UI and we're writing code. Why would we do anything with UI? But there are use cases. There are pretty nice use cases. I mean, other than having a really nice UI that you can share with a, I don't know, someone who doesn't know coding and stuff and would like to play with the workflows. Keep in mind that you can have your Azure Functions as components. Let's say you can bring your Azure Functions into a workflow in Logic Apps, and then you can have a Logic App workflow as part of a bigger picture. You can have a function triggering an event grid pushes the Logic App execution starts. Meanwhile, during the execution of the Logic App, during that flow, it can be consuming other functions and so on and so forth. And that would be really nice. One reason maybe to do that is to use the connectors that Logic App brings in. And the nice thing is, if you are going with the consumption tier, Logic App, you only get charged per action and per connector execution. So if it's not being used, you're not paying anything. Custom workflows and all that stuff. So pretty nice. One interesting use case is sometimes, and by the way, you can have from Logic Apps, you can have HTTP endpoints as well if you want to kick that out from HTTP endpoint. But one other thing is to have some beautiful timers. You want to run a job every 5 minutes. So I see a comment. Okay. I'm going to read it loud. Is it okay? Okay. I consistently recommend to customers, don't use Azure Functions or Logic Apps. Use Functions and Logic Apps. Love it. I was like, for a moment, oh my. Okay. Use Logic Apps whenever you're working with a tricky to use SDK. Beautiful. So that touches back to the connectors thing, because here's the deal. I mean, you can definitely build every connector that exists in Logic Apps yourself with your engineering team, but then you're going to maintain it. I mean, I see the point of, hey, we are running that, connector like, 50 million times a day, and it's, we have a huge end of bill at the end of the month. Okay, maybe in that case, it might be worth to do the engineering investment to build your own thing and then maybe maintain it. I don't know. But other than that, just get used to it and have Microsoft take care of those connectors, because otherwise it's painful. Anyways, I'm going to finish reading the comment. To manage direct communication with the service and do your code, dev, and functions works beautifully together. Exactly. I totally agree. Cool. Thank you for that. So the other thing I wanted to mention is API management. And you might not know this, but API management has a consumption tier as well. So there's a serverless API management version. It has a couple of features missing, but it kind of makes sense that those features are missing. For example, the developer portal is missing. Yeah, I mean, on the consumption tier, yeah, now that I'm thinking, it would be beautiful to have the developer tier, but it's okay. So the way we use, and when it comes to this, serverless approaches, I mean, you are using API management because you have some kind of an API, right? You pay per API operation, and the things that I can think that you can really, quickly leverage is, hey, have some kind of an API versioning decoupled from your functions, right? I mean, you can, but if you have that implemented into your function app itself, it's going to be another level of just separate the two. Let's make it easier. When most probably you're going to have multiple function apps and stuff as well in the background. Let's not expose that to the outside world. Let's just expose the API management endpoint. Do API versioning there. If you need, maybe you can do some API transformation. I have seen customers do API mocking for dev test scenarios for third parties to be able to do that. And for sure, if you're not doing anything, please do throttling. Put the throttling in front of it so that someone doesn't, that figures out where your API is. This usually happens, especially when you have a mobile application that is consuming, a public mobile application that is consuming the APIs, and you don't even protect like how many times they can call your API a second, right? I mean, it's not a huge security thing, but at least it's a step, right? Just make sure with a particular key, they cannot send more than with the particular IP. For some of these, throttling things, you might need to bring in a Redis cache, which isn't going to be serverless. But still, know that there is a serverless version of API management that has, a lot of the features that are useful, and it's a step forward. Okay, so I'm reading the chat. Event grid for when, logic app for what, and functions for how has been a successful pattern for several past customer engagements. That's beautiful. If that would be a slide, I guess we would need to explain that slide for a couple of minutes, but I have to think about it, by the way, but that at least sounds really smart. Event grid for when makes sense. Logic app for what, and functions for how. I see. So if it requires some tricky, implementation, how things are going to run, let's do it in the functions. By the way, there's one interesting thing that, obviously this is not a logic app session, but let's say you just want to write a little bit of a code in a logic app. There's an inline JavaScript editor that you can use where you can have JavaScript code run inline within logic app. So just letting you know. Oh yeah, I see the reactions. Okay, yeah, there's an inline JavaScript. You can literally type in there. Okay, cool. And it feels like I'm just in time, by the way. I will still show you. I'm not going to do the demo, but I will show you how easy that is. API management throttling, because I have that ready here. Ideally, I wanted to run this and show you, show off, send some load to the API and then turn the API management throttling in and see how that slows down things. But I guess we did cover the show off part enough. So in this case, what I have here is the say hello function imported into an API management service. If I go into the design and the get operation, what you're going to see, I'm kind of trying to make sure, how can I make this more clearly visible? Okay, for inbound processing, there's a rate limit by key component that I brought in, a policy that I brought in. So if I click on this, we're going to see the policy in action, and this is the line. So what I'm doing is, per subscription key for this API, I'm adding, hey, you can only do 2 calls every 60 seconds. This is the only line that you need to enable throttling. That's as easy. I mean, this one is a lovely as well. JVT token validation within the API management, not in the backend. That's another thing. Anyways, out of topic. Cool. So that was, assume that was a successful demo of API management throttling. Okay, I guess 1 minute left. And with that, I'm done. Yeah. Wow. I wasn't expecting to be exactly on time. Any questions? Perfect. No questions. I either did miserably failed and wasn't able to explain anything, or I did a beautiful job delivering the whole thing, and there are no questions left. Cool.
I think you did a beautiful job.
Thank you.